myself from Netherlands. I'm based in Netherlands, working for Johnson Labs. Johnson Labs is a company working in healthcare NLP and working with the big pharma companies like Roche, Kaiser Permanente, Novartis, etc. And I am leading the healthcare team over there to build NLP solutions to solve real-world NLP problems in healthcare industry. So today I'm going to cover our flagship component as a part of Spark NLP library. Spark NLP is a NLP library based like sitting on the shoulder of Spark itself. It's the only NLP library which can scale over the cluster. It has internal models which I'm developing at the moment. It has open source version which is downloaded more than 2 million times. And we have OCR solutions as well. So let me go over what we do in terms of name identity recognition, because it's also open source. That module is also open source in both license and so why do cognition? Is actually the first building block of natural language ER, like clinical entity linking to detect the terminologies from the clinical entities, or assertion status. Assertion status is like a negativity scope of a given chunk, which is coming from NER model.
Hello, I'm experiencing a bad connection.
Yeah, Vegel, I don't think we cannot, we are losing you sometimes.
Okay.
Let me do like this. I can present maybe presentation and you can just speak if you prefer. Let me just open the presentation quickly. Sorry for the technical issues. Okay. One second. Are you there, Vegel, or maybe it's not?
Sorry, guys, I dropped.
Yeah, we've seen it. Do you prefer me to share the video, maybe, like you just talk over? What do you think?
No, I can. I just
because we lost a bit your connection at the time.
Yeah. So I think I know why. So I just turned off the kids' games. It's probably because of that. Sorry for that. So let me.
Yeah, let's try. Otherwise, we can also share. Let's try like this. Otherwise, I can share.
So you see, right? Everything's fine. Right? Is everything good?
Yeah, looks good for now.
Okay, I'm sorry again. Sorry. Yeah, it's a crazy times. It happens. So NER is the first building block of any natural language understanding task, like assertion status to extract assertion status negativity scope of a given chunk. Like I have a fever and a sore throat. It's a present condition. If I say I don't have any pain or I don't have any headache, the model should be able to understand it's an absent. It's a negativity concept. Okay. Otherwise, we are not able to filter out the irrelevant entities while we try to build the story out of a clinical documents. Okay. Another one is the most important part of any NLU task is relation extraction, which is building the whole story by connecting the dots through NER models, entity linking models, or assertion status. Without relation extraction, you just have the ingredients, not the food itself. So that's why NER is first of all used for extracting structured data from free tasks, or automating record keeping or abstraction process, because thousands of records needs to be processed every day. And then for the clinical trials, people try to query free text data, which is another hard task in NLP. And then feeding the downstream task, as I just mentioned. And the last but not least is the features for the downstream machine learning model, because you can extract entities and then use them as a features for the downstream machine learning models. We have written several papers. All of them are built upon the NER models, because this is the flagship component of the Spark NLP library, which is also open source. It is based on BioSigma CNN chart architecture. I'm going to explain it in a bit. So right now in the clinical side, Spark NLP has around 30 different NER models, which can extract more than 100 clinical entities. So on the presentation, you see that several of them, like the pathology NER means that extracting medication entities out of 7 different classes, like dosage, frequency, duration, etc. So when you feed a prescription into any NLP pipeline, which is powered by clinical NER model, you would be able to get the frequency, dosage, and duration, etc. So that you can use the relation extraction model to link the dosage to the relevant drug, link the frequency to the relevant drug. For the anatomy NER, you can extract the body part, etc. So this is feeding every other clinical model inside Spark NLP library right now. So how does it work? We have several variations of the same models, because apart from what we see in data science or machine learning community, people coming from healthcare industry usually do not want to deal with building the pipeline from scratch, customizing their pipeline or solutions. As a developer, I'm sure you have seen these kind of clients before. So they just need some like a turnkey solution. To be able to do that, we train some variation of the same models that could already be done by customizing the pipeline, by saving time or saving efforts from them. We train different variation of the same model. For example, these are all trained on the same data, but with different labeling. This is NER drugs, for example. It's just extract the drug part, but the pathology extracts 7 different, which is another annotation style, like different type of annotation. And NER drugs large is combining the neighboring entities to the drug. So this is another trick that we can use, because you want your chunks as informative as possible to be able to use this chunk for the rest of the process, right? If you feed just metformin into a clinical resolver model to extract ICD or SNOMED code, you may not get anything, because it needs some dosage information. You would get some code, but it would ask you 10 milligram, 100 milligram, 1000 milligram. So that's why you need some informative part of the chunk. So that's why we have variation of the same models, okay? How do we use NER in healthcare? It's basically automating the abstraction process or creating features for the machine learning models, and then extracting knowledge from this unstructured task, which is highly underutilized in healthcare industry, but which is because healthcare has its own language, which is even harder for a human. We work with the doctor, for example, human physicians. We are getting help from them to annotate our data. And then when we work more than like 5 to 6 guys at the time, we end up with the training a model better than human accuracy, because it's very often, like oftentimes, 2 doctors do not agree on the same terms. So it's very tricky domain. So we can call it as an Uber domain specific field, okay? So we try to making predictions using electronic health records, like EHR. So making prediction using the free text data. So this is a sample use case. If you want to visualize what's going on, how do we use these models to solve certain problems? Assume that we are trying to predict if a patient would develop a metastasis on certain sites, right? So what do we need right now? We need to know how many times this patient visited our clinic, like we can say frequency of the clinical visits, or the number of positive mentioning of certain sites, right? It might say that, like, because this is a highly wild free task, right? It might say that the doctor might say that by looking at the pathology reports, say that there is a metastasis on the right shoulder, etc. But it needs to be verified in another report, right? So that's why you need to parse thousands of documents to create features and then train a model to be able to predict if a patient would develop a metastasis on certain sites or not. Okay, so this is the feature generation benefit of using NER models in healthcare. Or, for example, we published this paper last week in a scientific document understanding workshop. The goal was to be able to understand the scientific document like COVID-19 dataset, which is related to COVID-19 research. So there are millions of text documents producing every day, especially about COVID-19, and everyone tries to share their experience and their findings, right? So it's hard to summarize these findings and then extract some knowledge. So we applied our pipeline onto this COVID-19 dataset and tried to extract the top terms. This is just coming from the 100 document map, by the way. So we can say that cardiogenic oscillations are the most common observation from EKGs, while fever and hypothermia are the most common vital signs. So by using the assertion status related to all these chunks, you can also filter out and then say that, okay, the COVID patients usually high intubation or low fever, etc. Okay, so that's all connecting the dot in the entities that you are getting. So as I mentioned at the beginning, clinical NER model is feeding all the other sub-models that is used to understand a clinical document. The search status, the identification, which is highly popular field, by the way, the identification, because due to privacy issues, protected health information, which is abbreviated as PHI data, needs to be obfuscated or masked before sharing with the other authorities. So that's why you need to extract sensitive information like name, age, profession, etc. There are some rules for that. We call it HIPAA rules. You need to remove or obfuscate. Obfuscate means replace with the fake entities. And then you can share this document with the other people or with the other agencies without breaching any rules. So let's, I'm just trying to be fast. Let's talk about the metrics. We just run our pipeline, this NER pipeline, using our clinical word embeddings versus GLOW 6 billion embeddings. Using the same architecture, because in NER DL model that Spark NLP has, you can use any word embeddings that you have. You can train with Jan's team and then use here. You can download some embeddings from FastTask for any other language and then port into Spark NLP and then feed it into pipeline. So you will have a brand new NER model using a brand new word embeddings. Okay, so we compared these models' performances with the Stanza and SciSpicy. SciSpicy is the scientific version of the Spice library. These are all using the same data set and same test data set to be fair, to have a fair comparison performance metrics. And we also compared ourselves with the Stanza. Stanza is the Stanford developed NLP library, like Python version of the core NLP, we can say that. Okay, I assume that most of you already know core NLP. So out of 8 times, Spark NLP NER models beat these architectures 7 out of 8 times. So which is highly impressive. So let's see how we do this. This is another metrics. There are some clinical NLP challenges in clinical NLP domain. They used to call it I2B2. Right now it's called N2C2. And then there are some competitions running every year. So we compared our models with these architectures, and then these are what we get. The scores are really close to each other. We also publish these results. Okay, so and there is another commercial solutions out there, AWS Medical Comprehend, like pay-as-you-go solutions, or Google Cloud Platform Healthcare API. you query an API with your clinical text, and then you end up with some entities and then relations. So to compare the performance of Spark NLP, we did the same. We randomly selected 1,000 clinical documents from Mimic3 dataset, which is highly unstructured and ugly dataset. So we run it and then annotate it and then compare our results. Looks like Spark NLP clinical NER model does better than what they do. So why am I focusing on this? Which means that you would be able to use the same NER model for any kind of dataset on the open source because it's also free. Okay, so this is some sample outputs to compare AWS versus NER, Spark NLP. The architecture that is used in Spark NLP is BioSigma CNN char architecture. Since we wrote 3 papers about NER, there are some details that I would like to mention about. So this algorithm is proposed by the end of 2015 by Chewy and Nichols. And it's still state-of-the-art, one of the state-of-the-art models. In NER problems throughout history, there are several other solutions like rule-based solutions, some classical machine learning solutions like creating some features, number of capital letter, number of punctuations, etc., or part of speech tags to detect the type of a token. Because NER systems are token classification problem, we try to find the class of a token here. So that proposed algorithm is bidirectional LSTM CNN architecture. So we changed this a little bit, and then we ended up with a top 3 accuracy in terms of CoNNL 2003 NER challenge. Okay, you know that there's an NLPprogress.com, which is run by Sebastian Roeder, and then according to that ranking, when you train NERDL with BERT, as I told you before, you can use any embeddings, including BERT, to train this model. You just need to change one line of code to be able to use BERT, by the way. And then we have 93.3. And this is in production, by the way. So you can just train, and then you can just deploy. So this is the BioSigma when you try to annotate your data. So you assign labels for each token. B says like the beginning of a chunk. John Smith is a name. I is inside this chunk. Okay, so there are other schemas like BioES to make it more granular, but this proves to be better for our use case. So we try to detect what makes new as B location and York as the second token of this location. Okay, so we try to we train our model to detect the class of a token. And there are many tricks to improve the quality of these annotations, like close coordinators with the annotator, inter-annotator agreement metrics, etc., which is highly useful to get a higher score. When you end up at 90%, when you just play with the BioSigma or just play with the tokens or some punctuations or tokenization or sentence splitting, because these are all sentence-wise. Okay, the model only sees sentence by sentence. So you fit the model, at each iteration, you fit the batch of sentences to the network. Okay, so we basically assume that you have this sentence, we saw paintings of Picasso. This is a one sentence. We have 3 different features in NERDL. Okay, according to this BioSigma CNN char architecture. The first one is the embedding of the word itself. It can be Glove embeddings, it can be any custom embeddings. We use our own clinical embeddings for the clinical NER models. This could be Elmo, this could be Bert, this could be anything that you want. Right now, Spark NLP supports Elmo, Bert, Albert, and ExcelNet, so you can use any of them. The second feature is casing features. Casing features is because a word starting with capital letter is also an important indicator of being something, right? So, or all lowercase, or starting with capital letter and then ending with lowercase. These are all important features that you can use. And the third feature is the character feature. We use CNN embeddings for that characters. So because of the sequential manner of this network and using CNN for the char features, this is also immune to typos, which means that if you know that Picasso is a person name, okay, if you drop one letter, there would be a typo. but the model would still be able to find the type of this token, right? Given its sequence and its like characteristic features. So even you drop one letter, the model should be able to, if you train it well, you should be able to understand its true class. Okay. So these are the features that we create. Some people also use part of speech text. We don't use it in NERDL. We have NERCRF algorithm as well, which is using this one. And then we feed this into a network, concat here, and then feed it into BioSigma network. Okay, this is how it works. And then this is how we use CNN for the character features. And then we basically feed all the words into these networks by getting the token features, casing features, and character CNN features. And then model tries to predict its label after each iteration, and then due to backpropagation, like during backpropagation, it tries to minimize the error and then try to find out what makes the O, what makes company O, etc. Okay. And then rest is just the classification report or confusion matrix. This is exactly the same as what you do in any other machine learning evaluation stuff. Okay. So at the end, this is how you can train. On the left-hand side, you see how you can do this with any public CoNNL dataset. If you have some dataset in CoNNL format, we have some scripts to do that. You can check Spark NLP workshop repo. Okay, in that workshop repo, you will see some certification training notebooks that I prepared for the public notebooks or the healthcare notebooks. You can check and then find out how to prepare your own content, or you can just message me and then I will try to help. And then you just load it into a Spark environment and then load any Bert embeddings. This could be Glove embeddings, etc. Anything this could be. This should be word embeddings. Okay, so if you want to use this one, like Bert paste case, and then you use the R logic. This is called NERDL approach. In Spark NLP, this is like a building block, Lego. So you plug and play some models that you would need in your pipeline. For example, if you want to clean your data, and we have some normalizer. If you want to drop the stopwatch, there's a stopwatch removal component that you just put into your pipeline. Right now, this is the simplest version of a pipeline. You read the data set, CoNNL data set, with the CoNNL reader, get the Bert embeddings and feed it into NERDL approach, and then you train. There's a collab notebook for that. You can try in Spark NLP workshop report. This is how you can do the same in the clinical side. So for example, I use BC5 CDR clinical data set. The steps are exactly the same. And then you can customize this model further, like setting the dropout rate, number of EPO or learning rate or rate decay, etc. Okay. And then these are the collab notebooks that you can use if you want to try it further. There are another 90-minute talks on YouTube, which is the part of another webinar. You can just go ahead this notebook. This is when you write clinical name identity. When you Google it, you will find the Medium blog post, notebook, everything. Okay, you can just go ahead and try it, and then try to see if it works for your use case. If you don't want to use any Spark, there's an NLU library, which is the pure Python wrapper of Spark NLP. Spark NLP is already a wrapper of Scala because this library is written in Scala. Okay, so you can use Spark or just NLU library. Okay, import pip install NLU. You can also use that one to be able to use Spark NLP for your task. Okay, thank you very much. I hope you enjoyed, and I'm sorry that I interrupted before.